Hey guys, welcome back to Level 6 Math. Today we're looking at Lesson 10 in our Saxon Math. This is sequences in scales. This is something that you're going to use a lot in your life, so it's important that we get it down today. We're going to look at addition sequences, multiplication sequences. We're going to look at different things on a scale and learn how to measure it. This is an exciting lesson because now we're starting to look at patterns and doing like some code breaking. Now, it's pretty simple code breaking for today. But if you can get good at this, you're going to get good at breaking more complex codes or patterns later on. So we're looking at even numbers here. That's any integer or any number that can be divided exactly by 2. So like we know 4 divided by 2 is 2. So 4 would be an even number. 8 divided by 2 would be 4. It keeps the whole number. But 7 divided by 2 is 3.5. So that doesn't work. That would be an odd number. So anything that can't exactly be divided by 2 and result in a whole number, that's going to be an odd number. Now, that includes negative numbers. So negative 7 is still going to be odd. Negative 8 is still going to be even because negative 8 divided by 2 is negative 4. It's still an even number. It can go into a whole number. All right, looking at different scales, we have Fahrenheit. We're going to see this on the next slide too, but Fahrenheit's a temperature scale. That's just one example of a scale. It's used to show how hot or cold or something is, and it's written with this little degree thing. So if you're writing your temperature on your paper for your answers, you need to write the number plus the little degree thing, and then you have to indicate which scale it is. We'll use a big F or a capital F for Fahrenheit. We'll use a capital C for Celsius. It's really important that you include not just the degree scale or the degree symbol, but also whether it's Fahrenheit or Celsius, so we know which scale you're using. Water freezes at 32 degrees Fahrenheit. It boils at 212 degrees Fahrenheit, and we'll talk about where it goes Celsius in a little bit. A term is simply either a single number, a variable, or those things put together. So if we look at this expression, 4x is a term, negative 7 is a term. Think of it as negative 7, not 4x minus 7. Because we're just looking at different terms and we can rearrange the order of those terms. So 4x is a term, negative 7 is a term, and 5 is a term here. The equal is not. So that's just telling us what we're trying to do to solve this problem. But those are the terms. All right, so now let's look at sequences. This is where we start getting into codes. A sequence is an ordered listed number called terms. So these are terms just like we saw earlier that follow a certain rule. And the rule is where it turns it into a pattern or a code that needs to be broken. And that's one of the cool things about math is when it comes to patterns, they follow predictable pattern or sequences, they follow predictable patterns, all right? So here we see a pattern, 5, 10, 15, 20, 25. We're just counting by fives here, right? So our pattern would be an addition pattern or an addition sequence because it's just at plus 5 for each term. So the next 3 would be, after 25, we'd just do plus 5, which would be 30, then 35, then 40. B is not so easy. If we look 5, 10, we would think 15, but it doesn't go 5, 10, 15. So it's not adding by 5. So we have to look and see, well, what is happening here? The way that you can solve this pretty quickly for most patterns is first take the difference. So 10 minus 5 is 5. 15 minus 10 is 5. 20 minus 5. So that's where we're going to see it's an addition pattern. Here if we do 10 minus 5 is 5, 20 minus 10 is 10. So if we look at the difference, 20 to 40 is 20, 40 to 80 is 40. We can see, oh, what's going on here? Each time it's doubling, right? 5 times 2 is 10, 10 times 2 is 20. So, and we see that in the original sequence as well. 5 times 2 is 10, 10 times 2 is 20. So we know that our pattern here is multiplication. It's just going to be times by 2. Multiplied by 2 is our pattern, okay? So let's look at this sequence and determine if it's an addition sequence or a multiplication. So first we're going to check for addition. 3 minus 1 is 2. 9 minus 3 is 7. So it'd be 2, 7. 27 minus 9 is 18. 2, 7, 18. Do those follow a pattern? It doesn't seem like it. So then we'll try multiplication. 1 times what is 3? 1 times 3 is 3. 3 times 3 is 9. 9 times 3 is 27. 27 times 3 is 81. 81 times 3 is 243. And 243 times 3 is a bigger number that it would take me a minute to do mental math there. But we can see that this is definitely a multiplication sequence or a multiplication pattern multiplied by 3. Okay? All right, the numbers 2, 4, 6, 8 form a special sequence called even numbers. And so we say we're counting by 2s because all even numbers go in increments of 2. All right, an odd number also goes in a sequence by counting by 2s, 1, 3, 5, 7, 9. So they're divided into equal groups, just like even numbers. So think of a whole number, any whole number. I'm going to think of 7. Double that number. 7 times 2 is 14. Is the answer even or odd? The new number, 14, is even. And you'll find that no matter what whole number you picked, if you multiply it by 2, that's even. Because remember, even numbers are any number, whole number that can be divided by 2. So if we multiply it by 2, it's always going to be an even number. So that's a way to check whether or not your number is even or odd. Okay? So double that whole number and it results in an even number. Numerical information is presented in the form of a scale. We use different kinds of scale to display different kinds of things. To read a scale, we need to discover the value of the tick mark. And so like on a thermometer, you're going to see different tick marks. On a ruler, you're going to see different kinds of tick marks. So scales typically have tick marks. So here we're going to look at this scale, which is a thermometer, and it measures in both Fahrenheit and Celsius. Fahrenheit is typically what we use in the United States. Celsius is what everyone else in the universe uses, and it makes a lot more sense. Just like the US customary system doesn't make sense compared to the metric system, got a similar thing here with this scale. So a cool room might be around 68 degrees Fahrenheit. That's actually about what I keep this room to, 68, 67. I like it a little chilly, so 67 sounds good to me. The temperature at which water freezes is 32 in Fahrenheit, but look at Celsius. It totally makes sense. It's 0. So we measure it by a naturally occurring phenomenon. In Celsius, freezing is 0, boiling is 100. In Fahrenheit, 32 is freezing, 212 is boiling. Now, why does this matter? You want to know freezing point and boiling point because it affects your life. You need to know how, like we were cooking no-bake cookies yesterday, you have to boil your sugar and your chocolate for a while to get the right kind of crystallization. And so you have to know what temperature that's going to get to. With freezing, it's the fall here right now as we record this video, and we just had a cold weather pattern that came in, and they said it was going to get below 32 degrees at night. Well, we still have vegetables in our garden, and we don't want them to all go bad. So on the nights where we knew it was going to get under 32 degrees, we went out and covered our plants with tarps and our fruit trees with tarps so that it wouldn't get so cold there, because otherwise we would have had to throw away all those vegetables and fruits. So knowing freezing point really does matter, okay? So let's look at our hash marks here. If we go from 0 to 10, we can just count how many hash marks. 1, 2, 3, 4, 5. So if there's 5 hash marks from 0 to 10, we know each hash mark is worth 2. So then we can just count up if we're measuring 1, 2, and they're worth 2 each. So 2 times 2 is 4. So if we start at 0 and go to 4, that's just 4 degrees Fahrenheit. And remember, the degrees is the little circle and a big F for the Fahrenheit, okay? So we're going to mark it like that, 4 degrees Fahrenheit. And that's it. So we're just using scales today. Go ahead and practice this in your practice problems, and good luck.